Hello friends, I am Suneeta Phadkule, Professor in Mechanical Engineering, working at JSPM's Jaivantrao Sound College of Engineering, Hadapsar, Pune. This is our video lecture number 36, which is on the topic balancing of radial engines. The name of the graphical method is direct and reverse crank method. Learning outcome is you will be able to estimate the unbalance of radial engine using direct and reverse crank method. So let us see the recap. What we have learned in earlier lecture. See, reciprocating unbalance, we have learned that there are two types of unbalanced forces, primary unbalance and secondary unbalance. Okay, what is the value of maximum primary unbalance force? Mr omega square. And what is the value of maximum secondary unbalance force? Mr omega square upon n. This you will require here also, okay, in this lecture. Then we have also learned what are the primary and secondary cranks. Primary crank is actual crank and secondary crank is an imaginary crank. So if we compare these two cranks, their mass, length, angular velocity and angle between two cranks. So mass is same, R is R upon 4n for secondary crank, omega will be double and angle between two cranks will also be double. Okay. Now, today we are going to study balancing of radial engines. Okay. So the introduction, let us see first introduction. Okay, what do you mean by radial engines and what are the different types of radial engines? Okay. So IC engine are classified in different ways. One of the way of classification is on the basis of arrangement of cylinders. Okay, inline cylinders. We have already studied multi-cylinder inline engines. Okay, how to balance those engine, how to find out primary and secondary unbalanced forces and couples. Okay, so these cylinders can be 2-cylinder inline or 3, 4, 5, 6, 8-cylinder inline engine. Okay. Then second category is V engine. So it may be V6, V8, V12. Okay, that means 6-cylinder. Those are 2 banks will be there, 3 on one side, 3 on other side, or 8 engines, 4 on one side, 4 on other side, or 12, 6 and 6. Okay, these are usually used in luxurious say automobile and racing cars. Okay, the angle between V, that means 2 cylinders, 2 banks of the cylinder, maybe 60 degree, 90 degree or 120 degree. Then third category is X engine. The arrangement of the cylinders is in the form of X. That why the name is given X engine. Then next category is W engine. Next category is Y engine. And other category is opposed piston engine that is used in the racing cars. Okay. And the last category is radial engine. Okay. Actually, all these engines are nothing but falling under the radial category only. But specifically, radial engine, it is categorized as a separate one. And here for your syllabus, you have to study only V engine and radial engine. Okay, not specific. These are all the special cases of radial engine. You can say X, W, Y. But the special case of radial engine, which is V engine, is only there for your syllabus. And 3-cylinder, 4-cylinder, that is also there. Okay. Now, what do you mean by radial engine? Where do we use it? Okay. So in some engines, there are more than 1 cylinders in one plane. Okay, which is driven by a single crank. Okay, so though there are many number of cylinders, okay, all are driven by a single crank. Then center lines of the cylinders intersect with each other. Okay, if you remember the rotary engine which you have learned in theory of machine 1, this is nothing but a type of radial engine only. Okay, this arrangement is not very common, but whenever it is necessary to have large power to given volume or weight ratio, then this design is adopted. Okay, this is used in large luxury buses which requires more power. And in olden days, radial engine was used in aeroplanes. Nowadays, turbines, gas turbines are used in aeroplanes. Okay, so V engines are a special kind of radial engine having 2 cylinders. In radial engine, since the plane of rotation of the crank is same, there is no unbalanced primary and secondary couples if forces are balanced. Okay, see, this is your shaft. What we have learned in multi-cylinder inline engine, this is one cylinder, second cylinder, third cylinder, all cylinders were inline. But that is not the case with the radial engine. At one cross section of the shaft, okay, if you take cross section of the shaft, or if you see the side view, all cylinders are falling under the radial, along the radius of the circle, you can say. So all the cylinders are falling in the one plane only. That's why if your forces are balanced, your couples will also be balanced. So we need not study or need not examine couples in radial engine. We examine only forces. Okay, so we have to balance only forces, because if forces are balanced, couples will be automatically balanced, because all the cylinders are lying in single plane. Okay. Now, the method of analysis used for multi-cylinder inline engine is not used for radial engine. What are the methods we have used? Okay, for multi-cylinder inline engines, those are not used in radial engine. Okay, so other method is used in multi-cylinder in the radial engine that is known as a direct and reverse crank method. This is specifically developed for such radial engines. The balancing of radial engines can be examined by concept of direct and reverse crank. So we are going to study this concept in this today's lecture for a single cylinder, and then we will apply it for radial engine, which consists of many engines. Not many engines, many cylinders. Okay. Now let us see, what do you mean by direct and reverse crank concept? Okay. The method of direct and reverse crank is useful for determining primary and secondary forces in multi-cylinder radial engine, in which all the connecting rods are connected to a common crank. So as many cylinders are there, as many pistons are there, as many connecting rods are there, but there is only one crank which is common to all cylinders. Okay, this method gives simplified analysis of forces. Here primary and secondary couples are balanced because plane of rotation of crank is same. That means if there is no unbalanced forces present, there will be no unbalanced couples present. Okay, so this is basically a graphical method, but it is not drawn to the scale, the polygons. Okay, so this is the, now let us see this method. What is the name of the method? Direct and reverse crank method. So let us get understood the concept. Okay, so let us apply this method for primary unbalanced forces for single cylinder engine. Okay, so this is the actually, see, there are, you can see the mirror image of this crank and connecting rod. So right now you just consider half part of this system, this engine. That is, this is actual crank, which is known as a direct crank. This is connecting rod, which is actual connecting rod. Okay, then this crank is rotating in clockwise direction with the speed omega. Length of the crank is R, length of the connecting rod is L. Okay, now let us analyze the forces. Okay, crank at this instant is making angle theta. Okay, now see, whatever the reciprocating masses are there, that we imagine at crank pin. Okay, so what is the force developed by this crank pin? It is a centrifugal force, which is nothing but we treat it as an unbalanced force. So it is mr omega square by 2. Okay, mr omega square by 2. Why 2? Because half only we have considered, mr omega square by 2, 1/2 m omega. So what is the magnitude of primary force? We have seen maximum magnitude mr omega square. So half of primary force is mr omega square by 2. Now remaining half force we imagine to be placed at imaginary crank pin. Okay, so this is an imaginary crank. This is imaginary connecting rod. Okay, so this is known as a reverse crank, which is exactly mirror image of this crank. Okay, so if you see the mirror image along the line of the stroke, this is mirror image of the actual crank, which is known as a reverse crank. So if direct crank is assumed to be rotating in clockwise direction, reverse crank will rotate in anti-clockwise direction. If this angle is theta in clockwise direction, reverse crank will make same angle theta in anti-clockwise direction. Okay, now m by 2 is assumed to be placed here. So remaining m by 2 will be at imaginary crank, that is reverse crank. Okay. Now let us see what are the forces developed by such arrangement. So as I told you, this m by 2 will generate m by 2 r omega square centrifugal force, that is unbalanced force. Okay. Then here also it will develop the same force, that is mr omega square by 2. Now if you resolve this force into two component, vertical component, horizontal component. So what is the vertical component? As this angle is theta, vertical component is mr omega square sine theta by 2. Okay. And vertical component of this force, see this angle is theta. Okay. So this will be mr omega square into sine theta by 2. Okay. So this force means this component of this reverse crank force will be balanced by this component. Okay. So these two forces are balanced because these are equal in magnitude and acting opposite to each other. Now, what is the other component, that is horizontal component? It is mr square by 2 into cos theta. This is also mr square by 2 into cos theta. Okay. Now see this component plus this component. It will become mr omega square into cos theta. What is this type? Do you remember? This force is nothing but primary unbalanced force. See, go here. That's why I have written in the recap. See here, mr omega square into cos theta. This is your unbalanced primary force. So what has happened with the help of this primary? So this is in primary unbalanced force. Okay. So if we imagine half mass is placed at the direct crank, half mass is placed at the reverse crank. Okay. So these two components of the forces are balanced, but these two forces, these two components will be added and it will produce the same unbalanced force mr omega square cos theta. That's why this arrangement, which is an imaginary arrangement, is used to examine the forces, whether unbalanced forces are present or not. This is the concept. Understood? So instead of showing this mr omega square cos theta unbalanced force along the line of stroke, you can imagine half mass here, and same force will be remaining in the engine. Okay. Now let us read whatever we have seen. Consider the reciprocating mechanism as shown in above figure. Crank OC is called as a direct crank, which is actual crank. This is crank OC. Okay. Then which rotates at uniform velocity omega radian per second in clockwise direction. The unbalanced primary force due to reciprocating mass is what? mr omega square into cos theta. Okay. Now consider another imaginary crank OC dash, which is called as the reverse crank, which is a mirror image of the direct crank about the line of stroke. This reverse crank rotates at the same speed, that is omega, as that of the direct crank, but in the opposite direction. This we have already seen. Okay. So assuming that the mass of the piston M is divided into two equal parts and are placed at the end of each crank. So the vertical components of these masses balance each other, as we have seen. Mr omega square by 2 into sine theta will be balanced by mr omega square by 2 into sine theta. Okay. Whereas the summation of the horizontal forces will be mr omega square cos theta. This force is the same as inertia in the actual engine. Hence, the direct and reverse cranks generate exactly the same condition as witnessed in the actual engine regarding primary unbalanced force. Okay. So this is your primary unbalanced force, mr omega square into cos theta. Okay. Now let us examine secondary unbalanced force. Okay. See, the concept will remain exactly same. Only you have to replace the magnitude of the force. What is the magnitude of the secondary unbalanced force? mr omega square upon n into cos 2 theta. See, we have written in the revision, that is recap. See here. This is your secondary unbalanced force, mr omega square upon n into cos 2 theta. Okay. So what is the maximum magnitude of this secondary unbalanced force? mr omega square upon n. Okay. Now this secondary unbalanced force we have to analyze in the same fashion as we have analyzed primary unbalanced force. Okay. That means using the same concept. This is direct crank, this is reverse crank. So reverse crank is a mirror image of the direct crank. Okay, this is rotating with 2 omega speed. Okay, so reverse crank will also rotate with 2 omega speed, but in the opposite direction. Direct crank will make angle 2 theta in clockwise direction. Reverse crank will make 2 theta in anti-clockwise direction. Radius of the crank is r upon 4n. So reverse crank is also r upon 4n. Okay. So again, we have to imagine that m by 2 mass is placed here and m by 2 mass is placed here. That is direct and reverse crank. Okay. So what will be the force generated by this m by 2 unbalanced force? Mr omega square by n upon 2. Okay, m by 2. Mass is m by 2. Radius is r upon 4n and speed is 2 omega bracket square. Okay, if we simplify it, this 4 will cancel with this 4. So what is remaining? Mr omega square upon 2n. Okay, this is the force. Now if you resolve this into two component, vertical component will be sine 2 theta because this angle is 2 theta. Okay, so Mr omega square upon 2n into sine 2 theta. And this is horizontal component, Mr omega square upon 2n into cos 2 theta. Okay. Now this vertical component, again, it will be cancelled with this vertical component because of this force. This is also same, m by 2 r upon 4n into 2 omega bracket square. So its vertical component will be Mr omega square upon 2n into sine 2 theta. So this component will be balanced by this component. So what is remaining then? Again, you have to take the summation of this horizontal force plus this horizontal force. Okay, so it will become Mr omega square upon n into cos 2 theta. Okay, half plus half, it will become full, that is Mr omega square upon n into cos 2 theta. This is nothing but your secondary unbalanced force. Okay, so you can very well use this concept of direct and reverse crank method to examine, to find out how much is the primary unbalanced force and how much is the secondary unbalanced force in any radial engine. Okay, so let us read this. The same concept can be extended to the secondary unbalance by considering the direct and reverse crank. These cranks can be drawn similar to the primary crank, but using following changes. So radius of the crank is r upon 4n, angular speed 2 omega, angular position 2 theta. Okay. So referring to figure 2, it should be noted that the angles are measured in the direction of rotation from the line of action of the piston to the position of the crank. That means clockwise and anti-clockwise. Okay. The concept of direct and reverse crank can also be used to analyze V engine. That means two-cylinder engine specifically arranged in V type. However, in this case, individual solution for each crank position will have to be evaluated. In the analytical approach, as discussed afterwards, the generalized equations can be used for determining the primary and secondary unbalanced forces for any V angle and for any given position of the crank. That means what? Only for V engine, we are going to use analytical approach also and graphical approach also, that is direct and reverse crank method. Okay, so let us see balancing of V engine, that is two-cylinder radial engine. Okay, analytical approach, analytical method. Okay, graphical method we are going to study later on. Okay, because which is same for all radial engines, whether it is 2-cylinder, 3-cylinder, 4-cylinder. Okay, but analytical method we can apply only for 2-cylinder, that is V engine. Okay, because for as cylinder number of cylinders increases, complications or the analytical method will become more complex. Okay, that's why analytical method is not used for more than 2-cylinder. Okay, so let us imagine this V engine. This is one line of stroke, this is other line of stroke, this is cylinder C, cylinder D, piston, this is connecting rod AC, this is connecting rod AD, and this is crank. It is a common crank. Okay, OA. It is rotating in clockwise direction, say with the speed omega. Okay, so this is your V engine. Now this angle between two line of stroke, it is known as 2 alpha. It may be 60 degree, it may be 90 degree, it may be 120 degree depending on the application. Okay, so this angle is fixed. That means these are the, if we consider 4-cylinder, in V4, V8, V12. That means in this direction there will be say 3-cylinder. There will be 3-cylinder if it is V6 arrangement. Okay. Right now we are going to apply it analytical approach only for V cylinder, that is 2-cylinder engine. Okay. So a V engine is a 2-cylinder radial engine in which the connecting rods are fixed to a common crank as shown in figure 3. So these are 2 connecting rods which are fixed to the common crank OA. The line of stroke of piston is radial. Okay, that means along the radius of this circle, these are the line of stroke. Since the plane of rotation of the crank is the same, there are no unbalanced primary and secondary couples if forces are balanced. Okay. Now, to study the unbalances involved in the V engine, consider the following figure. So we have to consider this figure. Okay. Now see here. See, the forces are shown here. So now here you have to imagine that the crank is rotating, no? Okay. So let us assume any position of the crank OA. In the above figure, it was shown vertically matching with the YY axis. But now to analyze the system, we imagine that let us have the crank position at OA. Okay. So that means it is making angle theta with YY axis. Okay. This is axis XX. This is axis YY. Okay. This is the line of stroke. This is the line of stroke. So angle between 2 line of stroke is 2 alpha. Okay. Then this angle is theta. That means angle from YY axis of the crank. Okay. So now we have to find out what is the angle made by this line of stroke with the crank. Okay. See, for cylinder number, say cylinder number 1, or that is cylinder C. What is the angle between crank and line of stroke? See, this angle is theta. Okay. Theta minus alpha is nothing but this angle. Understood? So angle between crank and line of stroke. Okay. In normal engine, we used to show it theta. Okay. So here one more angle comes into picture, that is alpha, 2 alpha, because it's a V cylinder, V engine. Okay. So what is the angle made by the crank with the cylinder C, that is line of stroke of the cylinder C? Theta minus alpha. How this has come? This is angle theta and this is angle alpha. So this angle is theta minus alpha. Similarly, we have to find out the angle between this crank and line of stroke of cylinder D. So how much it is? See, this is theta and this is alpha. So this angle from crank to cylinder D, it is theta plus alpha. Okay. So in short, what we know? Angle made by cylinder C with the crank is theta minus alpha. Angle made by cylinder D with the crank, it is theta plus alpha. Okay. So let us read here. To study the unbalances involved in the V engine, consider following figure. The common crank OA is connected to the 2 connecting rods AC and AD. Okay. Let the crank move an angle theta from the YY axis. If the total angle of the V is 2 alpha, then the position of the crank when measured from TDC, that is YY axis of the piston C, will be theta minus alpha, and for piston D, it will be theta plus alpha. Okay, as I told you already, this is theta minus alpha and this is theta plus alpha. Okay. Now let us analyze the forces. So first we will study primary force. Okay. So what is the primary force along OC? See here. We have to, your primary force as, see, consider this diagram, direct crank. This one, primary forces. Here. See, this, your unbalanced force is acting along the line of stroke. Okay. So every force in all the cylinders we have to show along the line of stroke. MR omega square cos theta here. Okay. So in our case, that is V engine, how much is this force along the line of stroke? That is primary unbalanced force. See here, the primary force along OC, we will call it as a FPC, P for primary, C for cylinder C. Okay, so here, how much is this angle? mr omega square into theta, cos theta, but it is not angle theta now. Angle between crank and line of stroke is theta minus alpha. So what will be the primary unbalanced force along OC? mr omega square into cos theta minus alpha. Similarly, primary force along OD, that is FPD, primary force along cylinder D, it will be mr omega square cos theta plus alpha. Okay, very simple. Cos theta is replaced by theta minus alpha. Here also cos theta is replaced by theta plus alpha, because angle made by the crank with the line of stroke is not theta here, but it is theta minus alpha for cylinder C and theta plus alpha for cylinder D. Understood? Okay. Now the total primary force along YY. Okay, so let us take the component, that is we call it as a FPY, that is primary force along YY axis, that is vertical axis. Okay, so it will be component of cos alpha, FPC, component of vertical component of FPC plus vertical component of FPD, that is cos alpha. So see here. So the unbalanced force is here. Okay, it is like this. This is FPC and this is FPD. So what is this vertical component along with this along the YY axis? This angle is alpha. So it is along YY, it is FPC cos alpha, and here also FPD cos alpha. Okay, so here we have written what is the total force along YY axis? It will be addition FPC plus FPD into cos alpha. Okay, further part is only mathematics. Okay, so let us say put the value of FPC and FPD here. See, FPC is mr omega square cos theta minus alpha and FPD is mr omega square into cos theta plus alpha. So put here mr omega square, here we have put the value. Cos alpha is common here, and what else is common? Mr omega square. Okay, because there are in both the terms mr omega square is there. So mr omega square cos alpha into bracket, what is remaining? Cos theta minus alpha plus cos theta plus alpha. Okay, now imagine this is say capital A, this is capital B. So this will become cos A plus cos B. Okay, you have to recall that in mathematics you have learned that cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. Okay, so we have to write down this term in terms of multiplication. Okay, so this will remain as it is mr omega square into cos alpha. Now these two we have taken here. Okay, and then it is cos A plus B by 2. What is A? Theta minus alpha. So theta minus alpha plus theta plus alpha by 2 into cos A minus B by 2. This is A, this is B. So cos theta minus alpha minus theta minus alpha, because it's minus, divided by 2. Okay, so this minus alpha plus alpha will be cancelled out. So theta plus theta, 2 theta by 2. Okay, so only it will remain theta. So this is the term cos theta. Okay, now what is this term? Theta minus theta will be cancelling out. So what is remaining? Minus alpha divided by 2. So minus 2 alpha upon 2. So what will be remaining? Minus cos alpha. Okay, but what is minus cos alpha? Cos minus alpha? Cos minus alpha is plus cos alpha. That's why minus sign will not be there. Okay, because cos is positive. Cos of minus theta is always plus cos theta. So these two mr omega square will be as it is. Then this cos alpha will be as it is, and this will give you cos theta, this will give you cos alpha. Okay, so cos alpha into cos alpha, it will be cos square alpha. So FPY is equal to 2 mr omega square cos square alpha into cos theta. Call it equation 1. Okay, now total primary force along XX, that means horizontal component. See here, we have studied, we have divided into two components, now vertical component and now horizontal component. What is the horizontal component of this force? Okay, it will be in this direction. And what is the horizontal component of this force? It will be in this direction. So both are opposite. One is towards right, other is towards left. And it's a sine component. Okay, sine theta minus alpha, theta plus alpha. So you can write down like this. Where is that one? Primary force. This is we have seen. Now primary force along x-axis. Okay, so it is Fpx. P for primary, x for x in x direction. So Fpx is equal to Fpc minus Fpd into sine alpha. Okay, so it is basically Fpc sine alpha minus Fpd sine alpha. So sine alpha you have taken common. Okay, now putting the value of Fpc and Fpd. Okay, what is it? We have already seen here. Fpc is mr omega square cos theta minus alpha. Fpd is mr omega square cos theta plus alpha. So putting these two values, okay, we will get mr omega square common into the sine alpha will also be common. So what is remaining? Cos theta minus alpha minus cos theta plus alpha. Okay. Now what is the formula for cos A minus cos B? It will be sine. Okay, multiplication of sine term. So cos A minus cos B is equal to minus 2 sine A plus B by 2 into sine A minus B by 2. Okay, so you have to recall this formula. Now put the value. So mr omega square into sine alpha, as it is mr omega square into sine alpha, then minus 2, we have written here minus 2. Now here it is sine A plus B by 2. What is A? Theta minus alpha. What is B? Theta plus alpha. So theta minus alpha plus theta plus alpha divided by 2. Okay, then into sine A minus B by 2. So theta minus alpha minus theta minus alpha divided by 2. So this will be, alpha will be cancelling out. What is remaining? Theta plus theta, 2 theta divided by 2. That is sine theta. Okay, and here theta minus theta, it will be cancelling out. What is remaining? Minus alpha minus 2 alpha divided by 2. So it will become sine minus alpha. Okay, so this sine minus alpha is minus sine alpha, remember, and cos minus alpha is positive, that is cos alpha. So this sine minus alpha is minus sine alpha. So this minus sine will become plus. Okay, so what is remaining? The final Fpx 2 mr omega square into sine alpha, that is sine square alpha into sine theta. Okay, so this is the total force acting along x direction, total primary unbalanced force. Okay, now what is the resultant force? See, Fpy and Fpx, one is along x direction, other is along y direction. So the total resultant primary force on the engine would be vector sum of equation 1 and 2. So Fp, that is primary force, total primary force is equal to, it is a vector addition, square root of Fpx bracket square plus Fpy bracket square. Okay. Now let us analyze the secondary force. Secondary force, it is in the similar fashion you have to analyze. So first you write down secondary force along OC. That means along the line of stroke. What is it? FSC, that is secondary force for cylinder C. What is the magnitude of secondary unbalanced force? Mr omega square upon n into cos 2 theta. But here theta will be replaced by theta minus alpha for cylinder C. And for cylinder D, secondary force along the line of stroke, it will be FSD, that is secondary force for cylinder D. It will be mr omega square upon n into cos, not cos theta, it is cos 2 theta plus alpha. Why 2? Because for secondary crank, you know, angle is double. So it is cos 2 theta minus alpha, cos 2 theta plus alpha. Okay. Now take the total secondary force along YY axis. Okay. So see here, we'll go to the diagram. This is your secondary force, that is FSC for cylinder C. This is your secondary force for cylinder D. It is FSD. Okay. So take the component of this secondary force, the vertical component. Again, the secondary force, take vertical component. Okay. So it will be cos alpha. Okay. So let us see here, secondary force. So the total secondary force along YY is, you have to add it. Okay. FSY is equal to, that is secondary force along Y direction, is equal to FSC plus FSD into cos alpha. Okay. So put the value of FSC and FSD here. So what you can take common? mr omega square upon n. Okay. So mr omega square upon n into this cos alpha as it is. Now what is remaining? Cos 2 theta minus alpha plus cos 2 theta plus alpha. Okay. Now again you have to use here the formula cos A plus cos B. What is it? 2 cos A plus B by 2, this one. 2 cos A plus B by 2, sorry, this one. Plus hai na hai. Cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. Okay. So apply this formula here. That is here. So Fsy is equal to mr omega square upon n as it is. Okay. That 2 cos A plus B by 2 ka 2 we have written here 2, and this cos alpha is common here. Now what is the formula? Cos 2 A plus B by 2, because this 2 will remain as it is. So this will be A and this will be B. Okay. So A plus B by 2, that is theta minus alpha plus theta plus alpha. Okay. So divided by 2. Then cos 2 theta minus alpha, sorry, A minus B by 2, that is theta minus alpha by 2. Okay. So how will you write down this one? Theta minus alpha plus alpha will be cancelling out. So theta plus theta, 2 theta divided by 2. So it will become cos theta, and this 2 as it is. So this term will be cos 2 theta. Similarly here, only alpha will be remaining, minus 2 alpha, minus alpha will be remaining. So it will be cos minus 2 alpha, but cos minus 2 alpha will be plus cos 2 alpha. Okay. So what will be your force, total force along y direction, which is secondary unbalanced force, 2 mr omega square upon n into cos alpha as it is into cos 2 theta into cos 2 alpha. Don't worry, you don't have to remember this formula. You have to get understood the step-by-step procedure, that the same procedure you are going to use to solve the problem. Okay, you don't have to by heart the formula. Similarly, total primary force along x direction, that is horizontal direction. Okay, see again, these two forces are acting in the opposite direction, horizontal component. Okay, so this is your secondary force, its horizontal component will be towards right. This is your secondary unbalanced force for cylinder D, the horizontal component will be towards left. Okay, so that's why there will be minus sign. Okay, so total horizontal force, which is secondary force, secondary unbalanced force, it will be Fsx. That means secondary force in x direction, it will be Fsc minus Fsd into sin alpha. So this is secondary unbalanced force for cylinder C, for cylinder D. Okay. Now put the value of Fsc and Fsd. Okay, this we have written here. So put this value mr omega square upon n into cos 2 theta minus alpha. Fsd is mr omega square upon n into cos 2 theta plus alpha. Okay. So here putting the value of Fsc and Fsd. Okay. So mr omega square upon n common. This sin alpha will also be common. So what is remaining in the bracket? Cos 2 theta minus alpha minus cos 2 theta plus alpha. Okay. Now again you have to apply here the equation, that is cos A minus cos B. Okay. So you know it is 2 cos 2 sin A plus B by 2 into 2 sin A minus B by 2. Okay. Now see, this mr omega square upon n will be as it is. It's minus sign for sin. So minus 2 mr omega square upon n into this sin alpha as it is. And now it is sin 2 A plus B by 2, that is theta minus alpha plus theta plus alpha by 2 into sin 2 A minus B by 2, that is theta minus alpha by 2. Okay. So here again alpha will be cancelling out. So 2 theta by 2, only theta will be remaining, and this 2 will be as it is. So the term will be sin 2 theta. Okay. Then here theta will be cancelling out. It will be minus alpha, that is minus 2 alpha by 2. It will be sin 2 minus alpha. It will become minus minus plus here. Okay. So your component of secondary force along x direction is 2 mr omega square upon n into sin square alpha, because this sin alpha into this sin alpha. Okay. Sorry, not sin alpha. It is not square. Sorry, by mistake I have written it. It is simply sin alpha. Sin alpha into this sin 2 theta into this sin 2 alpha. Okay. Please correct this mistake. Now, what is your total secondary resultant force on the engine? It will be summation vector addition of Fsx and Fsy. Okay. So resultant force, secondary unbalanced force will be Fs is equal to square root of f sx bracket square plus f sy bracket square. Okay. Now let us study the special case of this engine where this 2 alpha angle is 90 degree. See here, this 2 alpha, if this 2 alpha is 90 degree, what will be the primary and secondary unbalanced forces present in this V engine? Understood? So we are going to study now special case where 2 alpha is equal to 90 degree. Okay. So let us see. Now let us analyze primary force first. Okay. So total primary force along YY axis. What we have found out? FPY is equal to 2 mr omega square into cos square alpha into cos theta. Okay, if you no need to imagine this equation, you can directly start your problem solving right from the first principle, which you have seen already here. Okay, or you can remember this formula, anything whichever you wish. Okay, so putting 2 alpha is equal to 90 degree, and so alpha is equal to 45 degree. Okay, so putting in this FPY, 2 mr omega square as it is into cos square alpha, that is cos square 45 degree, into cos theta. Theta is unknown. Theta is continuously changing. It's an angle between crank made by the vertical axis. Okay. So what is cos 45? 1 upon root 2, and cos square means 1 by 2. So 1 by 2, and these 2 will get cancelled. So what is remaining? Mr omega square cos theta. Okay. Call this equation 7. Similarly, find out total primary force along x-axis direction, that means horizontal component. Addition of both the forces for cylinder C and cylinder D. So which is Fpx is equal to, that is primary force along x direction, is equal to 2 mr omega square into sine square alpha into sine theta. Okay, so again putting 2 alpha is equal to 90 degree, that is alpha is equal to 45 degree. What are you getting? Fpx is equal to 2 mr omega square as it is into sine square 45 degree into sine theta as it is, because theta is a variable parameter. Alpha is fixed angle between two cylinders. Okay, so again sine 45 is 1 upon root 2, so sine square is 1 upon 2. 2 will get cancelled with these 2. So what is remaining? Fpx is equal to mr omega square into sine theta. Okay, so this is your equation number 8. Okay, now from equation 7 and 8, it is interesting to note that the resultant primary force for 2 alpha, that is 90 degree in the direction of the crank, is vector sum of these two cranks and is equal to total resulting primary force along the crank. Okay, so you have to add it, Fpx and Fpy. So it's a vector addition. So Fp is equal to square root of Fpx bracket square plus Fpy bracket square. So when you put the value, what are you getting? Fp is equal to mr omega square. You can take common. So what is remaining? See here. Here also mr omega square and here also mr omega square. Okay. So mr omega square and square of that one. So when it will be out of square root sign, it will simply become mr omega square. And what is remaining inside the square root? Sine square theta plus cos square theta. Okay. You know it is 1. So primary unbalanced force, total primary unbalanced force is simply mr omega square. Okay. Now you have studied in rotating unbalance that how to balance this force, say in a single plane. Okay. So just provide the mass, that is mb, at suitable radius, that is rb, to balance this force m into r. Okay. Therefore, it is obvious that primary force can be completely balanced by a suitable mass mb at a suitable radius rb, which is opposite to the crank, such that mr is equal to mbrb. Okay. Now let us analyze the secondary force for this special case, that is 2 alpha is equal to 90 degree. So what is the total secondary force along YY direction, that is vertical direction? You know, you have found out FSY, that is secondary force along Y direction. It is 2 mr omega square upon n into cos alpha into cos 2 theta into cos 2 alpha. Okay, where theta is the variable parameter, alpha is the fixed angle. So putting 2 alpha is equal to 90 degree, that is alpha is equal to 45 degree in this equation. So what are you getting? FSY is equal to 2 mr omega square upon n into cos alpha means 45 degree cos 2 alpha means cos 90 degree, and cos 2 theta as it is. Okay. So what is cos 90 degree? It is 0. That's why secondary force along y direction is 0. Okay. Now let us find out the total secondary force along x direction, that is horizontal component. Okay. So what is it? Fsx is equal to, that is secondary force along x direction is equal to 2 mr omega square upon n into sin alpha sin 2 theta into sin 2 alpha. Okay. So again putting the value of 2 alpha is equal to 90 degree, that is alpha is equal to 45 degree. So put here Fsx is equal to 2 mr omega square upon n into sin alpha means 45 degree, sin 2 alpha means sin 90 degree, and sin 2 theta as it is. Okay. So what is sin 90 degree? Sin 0 is 0, so sin 90 degree is 1. Okay. So what is remaining? And what is sin 45? It is 1 upon root 2. Okay. And sin 2 theta as it is. So 2 upon root 2 will be root 2 mr omega square upon n as it is into sin 2 theta. Okay. So this is the secondary unbalanced force which is acting along the x axis. The magnitude will be root 2 mr omega square upon n, and it is a harmonic force because sin 2 theta term is there. It is continuously changing as theta changes because your crank is continuously rotating. Okay, so from 10 and 11, it may be concluded that the secondary force along xx direction is a harmonic force as it includes term sin 2 theta, this one, and can be balanced only by the special method adopted. So these may not be completely balanced, or some special methods can be adopted to balance this force because this is a recurring force. Continuously it will be changing. It's a harmonic force. Okay, sinusoidal. Understood? So this is your theory for direct and reverse crank method. See friends, in next lecture we are going to solve 3 problems, okay, which are based on radial engine, but one problem will be definitely on V engine, which we are going to solve by analytical method also and by graphical method also. And remaining 2 problems, that is on 3-cylinder engine, 3-cylinder radial engine, we are going to use only direct and reverse crank method. Okay. Now see, actually speaking, direct and reverse crank method which we have studied here, that we have studied only the concept which we have applied to single cylinder. Okay, but now how to use this concept for radial engine, that is for 3-cylinder, 2-cylinder or 4-cylinder, that is very interesting. And I'm sure if you read from the book how to show those angles, you will not understand, you will get confused. Okay, so please don't miss my next lecture, which will be the last lecture for unit number 4, in which we are going to solve 3 problems on radial engine. Okay, so thank you very much.